what is resonance energy? Right. It is defined as the difference between the actual bond energy of the molecule and that of most stable structure of the resonating structures. Characteristics. Characteristic features of resonance hybrid. Okay, this is only for your entrance exam because in school they don't ask. The resonance hybrid is more stable than any one of the canonical form. That is, it has less energy. Again, in a resonance hybrid, the bond lengths, the bond lengths are different from their canonical form. The bond length in a molecule become equal. Third, the canonical forms do not have any real existence. That is, only the resonance hybrid as real very interesting thing, huh? Because we have learned initially in chemical bond that we have two types of bond between atoms in a molecule. One we call it bonding, or and second one is called the covalent bond. So ionic compounds are linked by the two different types of ions with the electrostatic force of attraction. We call it ionic linkage. So they are polar because you have positive and negative. And covalent molecules are being formed by the equal sharing of the electrons. So they are non-polar. But you will find very interestingly that today we are going to discuss that covalent molecules also can behave like a polar molecule. They will not exist in the form of ions, but they will show you the property of the covalent molecules. And you will find there are several ionic compounds are there, which you call them as salts. And they behave like the covalent molecule. I told you that salts are soluble in water, but interestingly, dear, you will find these are not soluble in water. Okay? And when, suppose by this time your school opens and if you do some experiment in the laboratory, you will find that this type of compounds you can prepare within no time. So today we are going to discuss about the polarity in covalent molecules and the covalent character in ionic molecules. Okay, so now we will write polarity of covalent. Polarity in covalent bonds. Okay, see here, very interesting. Suppose I have taken a molecule A. So you know that I'm not writing other electrons there. So this is the electron of A and this is the electron of A. Alright, let me write that. So this is the Lewis structure. So how do you write it? We write it. This is the bond structure. See here. Here the electrons are equidistant from both the nuclei. Alright. Similarly, I can have and don't write this. Similarly, you will find we can have a molecule like AB. Okay. So in AB, you will find that we know that electronegativity of the elements keep on changing when you move from left to right. That is, when you move from left to right, electronegativity increases. So in our alphabets, we have 26 alphabets are there. So B is just after A. So in that case, what you will find? If it is an element, in that case, a very small difference will be there between the two atoms, electronegativity of two atoms. So that also will be, you will find, here also you will find the electrons will be almost in the middle of A and B. Now suppose I have taken A, X. See, X is very far away from A. All right, we know when we move from left to right, electronegativity increases. When the bond formation has taken place, they had an understanding that we are going to share the bond pair. But in actual practice, what has happened? After the formation of the bond, X, because of higher effective nuclear charge, pulls both the electron to this side. So what you will have now? You will find this. See. Now, this A cannot find its electron nearby. So it feels that I have almost lost the electron. Okay, that is, it develops electron deficiency. And in case of X, it has already got back its electron, and the electron of the other atom has approached nearby. Now the density of electron around the X has increased. So how will you, without showing this electron, how we are going to show? So I can write this is equivalent to A X. This is del plus and this is del minus. Okay, so this bond between this covalent bond between the A and X is called polar covalent bond. So theoretically we know that the electronegativity to adjacent atoms are not same. All right, in the same period, electronegativity adjacent electrons are not same, atoms are not same. So how can you define polar covalent bond? In the simplest way, we can write a covalent bond which is formed between two atoms of difference in electronegativity is called a polar covalent bond. Polar covalent bond. Huh? Okay, now this molecule, what we will call it? So what we will call now? What is our inference here? Inference is that AX is a polar molecule. Okay, now we are going to write here polar covalent bond. In your book, long definition will be there. You don't have to mark up. You'll write it with your own words. We'll write now here the covalent bond exists between two different atoms with different electronegativities. Covalent bonds exist are called polar covalent. Okay, now you write these examples with this. Okay, example you can write like H. Okay, we can write here now H. See, fluorine is much more electronegative than hydrogen. Oxygen is much more electronegative than hydrogen. And how to write here? We write here del plus, del minus. Del plus, del minus, del plus. Then we'll write like this. NH, ammonia, okay? Del plus, del plus, del minus, del plus, etc.
Done.
Okay. Please remember, anywhere if a difference is being created, some movement or displacement is always noticed. Okay? See, suppose few drops of water fell on a table, it remains there. But if you lift one part of the table, you'll find water will start flowing. So any type of difference or gradient, if it is being created, some sort of movement is there. And whenever movement is there, we always use the word moment. That is, moment has come from momentum. Okay? So in that case, now we are going to discuss about the dipole moment. Why do you call it dipole? Because we have created two types of charges. Okay? So that is because of that we call it dipole moment. Okay. After that, I want to write you one line. Right. Greater the difference in the electronegativities in the electronegativities of the atoms. Okay. Wait, let me put the marking of the atoms forming the bond. Forming the bond greater will be the charge separation. charge separation. Why? See, this difference of charges is called charge separation. And hence, greater will be the polarity of the molecule. All right. Example. See, polarity. Okay, polarity. HF. See here. Fluorine is having the highest electronegativity. Then it will be more polar than HCl, more polar than HBr, more polar than HI. Why? Because the electronegativity decreases from fluorine to iodine. So the charge separation will between the hydrogen and the halogen atom will gradually decrease. So the polarity of the molecule also will decrease. Dipole moment is defined as the product of the magnitude of the charge separation and the distance between the centers of positive and negative charges. It is represented by mu and has a unit d. What is distance for? Distance for Debye. You know the name of the Debye, you have already heard it, Debye-Huckel. So how can you write mathematically? So mathematically you can write here dipole moment is equal to charge into distance. Distance of separation. So if I put symbol mu is equal to q into d. Charge. This is charge and this is the distance.
Sir, done.
Now we are coming to the interesting part of it. See, I told you that if it is this, so that it is this and this is this. So in this case, which way the charge is moved? This way. So we have to mention it in this way. Good. So if whenever anything has a fixed direction, okay, we call it as a vector quantity. So this is the one. How do you say dipole moment? Without giving, this is a normal arrow. For dipole moment, always you use this. So that indicates this is a dipole moment. All right, the dipole moment. So right now, it is a vector quantity. One E. That is, it has both magnitude as well as direction, as well as direction. The overall value of dipole moment of a polar molecule depends on its geometry and shape. That is, means what? Suppose there are many bonds are there. So we will see the direction in which displacement is taking place. We will find out its dipole moment. After that, we will add it. If it is 0, then we will say the molecule is non-polar, it doesn't have a dipole moment. But in that case, if it is non-zero, then we will say the molecule is polar and has a dipole moment. Okay? That is vectorial addition of dipole moment of the constituent bonds. the dipole moment, this separate, huh? Along a bond is known as bond moment. So when you add all the bond moment, after that, what about the result that you get? If it is zero, sorry, when you add all the bond moment, that is total is called, that is the one for the dipole moment of a molecule. Dipole moment of a molecule is obtained by the addition of individual bond moments. Example, okay? So right now, yeah. A symmetrical molecule is non-polar even though it contains polar bonds. Okay? See here. What is a symmetrical molecule? This is if I pass a mirror through the middle of the molecule, you will find the original molecule and the reflection is same. Suppose if we stand in front of a mirror, so does it your image matches with the original one? Does not match because your right side looks like left side. All right. See here. Say I have taken here carbon dioxide. Why? I told this is already being told that if you know the dipole moment depends upon the structure of the molecule and their geometry. So you can do other way also because molecules are not visible to us. So if you can calculate the dipole moment, you can even predict the structure. See, the dipole moment of this molecule, carbon dioxide, is found to be 0.00 Means what? This molecule is non-polar, but it's very interesting. You know, there's a large difference of electronegativity between carbon and oxygen. This is carbon oxygen bonds are polar. Then why it is showing? Why the dipole moment of carbon dioxide is 0? See, very interesting. So in that case, you'll find look. See here, I'll write the dipole bond. This is the bond moment. This is the bond moment. Is it not one is cancelling the other? Huh? Is it not cancelling? Huh? So in that case, you will find dipole moment of this molecule will be 0. Why? One bond moment cancels the other bond moment because they are opposite to each other. All right. So what is the structure we should call it? From there I told you can find out. So this structure is linear. Okay. But suppose I have taken this molecule, this COS. In that case, you will find that dipole moment is not equal to 0. Why? Why it is not 0? This is also a linear molecule. This molecule is also linear. Okay, but my electronegativity of sulfur is less than that of oxygen. So when you add it, okay, when you add the bond moment, in this case, you will find that this is larger than this. So in that case, the dipole moment of the molecule will not be 0. So what we can write now? Even though COS molecule is linear, but the bond moment of bond is more than bond. Hence, COS is a polar molecule. Means what? Mu is not equal to this.
Excuse me, sir.
Yes.
Sir, can you please explain this again? I did not understand the
Very
difference
nice.
between the two.
Yes. Yes. Why not? See here. Think it is a tug of war. It is a rope. Here is a mark, and they tie it with some hanky. Okay. Say here. Okay, these are the persons of pulling. If the strength of both the persons are same, will the mark move in any direction? Huh? This will not move because this force is being neutralized by this force. But if the situation is different, if you find that these people are little weaker, see, I have used long arrow, shorter. If these people are little weaker than this, then which way this rope will move? Left hand side or not?
Yes, sir.
Yes. See here, we know that sulfur is below oxygen. So electronegativity increases from left to right, and this is increases and decreases from top to bottom. So here you have oxygen and here you have sulfur. So which is less electronegative? Sulfur. If the electronegativity of sulfur is less, in that case the bond moment of carbon sulfur will also be less than that of carbon oxygen. Clear?
Yes, sir.
Ah. Okay, now. We have to understand very clearly because nobody is going to teach you dipole moment in future. Here only you have to understand everything. Now say suppose I have taken here DF3. See there, fluorine is the strongest electronegative element. Okay? Here we find is dipole moment is equal to 0. It's very strange. You have a bond between boron is far away from fluorine. So boron fluorine bonds are extremely polar. Then why the molecule does not show any polarity? So from there we can find out the structure. See here, it is a planar molecule, two-dimensional. Okay, we call it. See if I write it, join the outline. What we call it? We call it is a trigonal planar. And what the bond angle we have here? Bond angle is 120 degrees. Bond angle is 120 degrees. When we go to the hybridization, we'll explain everything. Don't worry. Trigonal planar. Now why? See here. This bond is polar. So now I'll grab it. This is having bond moment, and this is having bond moment. Okay. So in that case, why does it show? It's very interesting. You have learned in physics or maybe in mathematics. Okay. Say this is an object. This object is for you is a little heavy. One of you cannot pull it. So what did you do? You have tied two ropes. And here you are pulling it and your friend is pulling this one. Okay, pulling this one. So in that case, which way the object will go? Object will go in this direction. Is it not? Huh? So this is called resultant force. So here you have applied force 1 and here you apply force 2. So in that case, the object will move in between. So what you call this one to be? Resultant force. It is you have to add both the forces and divide it by 2. Actually, it's not that so simple. It has an equation. That equation is not required for you. Okay. So this is resultant force. So now see here. So this the bond moment of boron and fluorine. But at the same time, boron is being pulled by 2 other fluorine also. So what you are going to have now here? Okay. So this is the bond moment and this is the resultant bond. Okay, so if I add this bond moment and this bond moment, and if we divide it by 2, is it not equal to this? Huh? Hello. See, this bond moment of this one, and this one is same only. So I have added one bond moment. I have added another bond moment, and I divided by 2. Then should I not get this? Huh? So in that case, is it not equal to this? Huh? So what we can say here? We can say the bond moment of BF bond are neutralized. I don't have neutralized. I write cancel. Are cancelled by the resultant bond moments. Resultant bond moment. And hence BF3 molecules are BF3 molecule is non-polar. See, this non-polar molecule means what? A molecule which have polar bonds, but the molecule can behave as non-polar because of this factor. If the bond moments are cancelled. So how can you cancel the bond moments? One bond moment may cancel the other moment if they are diagonally opposite to each other, exactly opposite to each other. Second, what is the second way? If one bond moment has a resultant bond moment in opposite direction, then they will cancel each other. So same thing you will find. This type of example can be shown by this, that it can be BCl3, AlCl3. All these cases you will find the bond moments are different. So if it is so, immediately you can predict that these molecules are having trigonal planar geometry. They're having trigonal planar geometry.
You're done.
So done.
Yes. All right. Now, see this molecule. This molecule is symmetrical. I forgot to tell you. This molecule is symmetrical. Why do you call it symmetrical? See, if I pass a mirror through this, is it not the upper part is reflection of lower part? Hello,
Yes, sir.
do you understand? See, boron and fluorine will lie in the plane of the mirror only, so they will not be visible. Is it not upper half is reflection of lower half?
Yes,
Hello?
sir.
Very good. So we can call this molecule is having a plane of symmetry. Plane of symmetry. Okay, now see here. This is you. I don't know how you look like. See here. Suppose if I pass, I cut it into equal half, exactly in the middle of the body. If I cut it, will it be symmetrical?
Yes.
No, sir.
Yeah.
Why? Tell, if you say no, why it is like this? Exactly in the middle. I have dissected you. Tell why it will not be symmetrical. One person has told me it is symmetrical, and you are telling it is asymmetrical. Why? Bolo.
Sir,
Yes.
The left part of our body is exactly the right part of the same, like the right part of the left part of my body only, sir.
Achha,
So it's
okay.
symmetrical.
Okay, I understand. Then let the lady tell me why it is not. Why she is saying no. Did she think anything before telling the answer, or just like that wild guess she told? Hello.
sir, actually, our face is not symmetrical, so I don't think so. Our body would be.
No. See, you find it is a perfect body. That person did not meet with an accident. He doesn't have deformation outside. Nothing.
Sir, I don't know.
But actually, you are correct. Actually, you are correct. You know
Thank you,
why?
sir.
Don't say thank you. You don't know the answer. See here. Your heart is on the left. Do you have two hearts? And your liver is on the right. Human body is not symmetrical. Okay. But if you cut, in the left side will have the heart. Right side of the body will not have a separate heart. Okay. And the right side of the body will have liver, and left side of the body will not have liver. Please remember, human body is not symmetrical, even if the external appearance is found to be symmetrical. Okay. Science is a beautiful thing, okay? If you are a little sincere, you will be able to answer everything. Okay, now see here. We'll go for CH4, methane. Here also you'll find the dipole moment is 0, but we know the electronegativity of hydrogen is much, much lower than that of carbon. That is, every carbon-hydrogen bond is having a dipole moment or bond moment, is having bond moment. Then why is dipole moment of the methane molecule is 0? Okay. So, have you seen a methane molecule? Hello.
Yes, sir.
Yes, you have seen.
Yes, sir.
Where?
So in the book.
Book, sir.
But that is in 2-dimensional. You see the 3-dimensional picture of methane. See. Can you see it?
Yes,
Huh?
sir.
Yes, sir.
Very good. Now see here. In that case, look, I'm holding the methane because we always see like this. Okay? You hold it like this. Look, dear. Between carbon and hydrogen, which is more electronegative? Which is more electronegative?
Carbon.
Yes. So in that case, see here. In that case, the bond moment will be in this direction. This, see, hydrogen is less and carbon is more. So in that case, bond moment will be in this direction and this will be in this direction. So which of the force is moving? Towards carbon. This is also moving towards carbon. So resultant force will be in which direction? It will go below. Understood? It will go this side. And for this, see here, for this it will come in this direction, and for this is coming in this direction. The resultant bond moment will be in this direction. So do you not find here that one resultant bond moment cancels the other resultant bond moment? Hello?
Yes, sir.
Yes, sir.
Really you are saying yes, sir? Huh? Or after understanding you are saying yes, sir?
So can you please explain again?
Yes, because it is not a classical music. Whether you understand or not, you have to shake your head, na? Other people will think that fellow doesn't understand music. Huh? Maria mata pati mutor. See here. Very interesting. First example I have done. What is the first example? See here. This. What did you write here? That is one bond moment carbon oxygen bond moment cancels other carbon oxygen bond moment. See here we have not taken any resultant. So this cancels this. So in that case, it is mu equal to 0. Second example I have given here is this. This is the bond moment. And this is the resultant bond. See here. So this bond moment will be cancelled by the resultant bond moment of this one. Let us go for this. When you go for this bond moment, this will be cancelled by the resultant bond moment of these two. When you go for this one, this will be cancelled by the resultant bond moment of these two, which will come in this direction. So what do you find here? That BF resultant bond moment cancels the BF bond moment. So here resultant bond moment cancels the bond moment. The second example. Now I'm going to draw for methane. Okay, now see methane. Okay, so methane, how I'm going to draw? Look at the structure. I will not draw it like this now. Okay, I will now see. Why did I draw it like this? Look at this. Is it not in the plane? So if it's the plane of the board, this one I'm drawing it like this. Is it not one is facing towards you? If this is the plane of the board, is it not above the plane? Huh? Above the plane or not? Hello?
Yes, sir.
Yes, sir.
Yeah. Above the plane, we have written with thick line. And is it not behind the board? See here, behind the board or not? This is the plane.
Yes, sir.
So this is being written with the broken line. Okay, this type of structure of the molecule is known as dash and okay. See here. See, for this two, this is the bond moment. This is the bond moment. So this is the resultant bond. So this is the bond moment. This is the bond moment. And this is the resultant bond moment from the above. Now, see, in this case, this is the bond moment. This is the bond moment. Which way the resultant will go? This is the resultant bond. So, here, what we write now? The resultant bond moment of polar carbon hydrogen bond cancel each other. Okay. Resultant bond moments. The two are there. And hence molecule, oh sorry, and hence CH4 molecule is non-polar. See, they are having polar bonds, but the molecule is non-polar.
So done.
Dance and bonus in Neoga. Could you understand or not? First you tell. I told you this is not a handwriting class. Butchesni. Hello?
Yes, sir. Bucci.
Sir, understood.
Acha. Okay. But in your exam, they may not give you this. Right? So they may give you. Arrange the following molecules in order of decreasing dipole moments. Example, say they have given here CHCl, CH3Cl, CH2Cl2, CHCl3, and CCl4. Let proper let. Jol khai.
Yes, sir. So done.
Done. Acha,
Yes.
very good. So let us check one by one. Okay, so let me start from here. CCl4. So what I will do now? See, this is Cl, this is Cl, this is Cl, and this is Cl. See, CCl4 molecule is a symmetrical molecule. We will not see it like this. We'll see you like this. Okay, see. This is Cl. Look at nicely. Can you see all the atoms now? Hello? All the atoms
Yes,
are
sir.
visible. Ah, very good. See here. This is Cl, this is Cl, this is Cl, this is Cl. Now, this is the plane. If I pass a plane through this, is it not? This is a reflection of this, and this is the reflection of this. Okay. I'm passing a plane through this. Mirror is going through this plane. So this, and this will not be visible. Only this will be visible and this will be visible. So is it not the reflection and the original molecule look same? Huh?
Yes, sir.
Acha. Now I'm passing the mirror through from this bottom. I pass it. So what you will find? This will be here and this will be here. Is it not the same? Huh? All right. See, first I passed it like this. Second I passed it like this. So I find this molecule is symmetrical. Okay. Now see here. Here the situation is different. Earlier in methane, we have found carbon is more electronegative than chlorine. Now we find, carbon was more electronegative than hydrogen. So the bond moment was moving towards the carbon. Here the case is reversed. Chlorine is more electronegative than carbon. What will happen to the bond moment? Now the flow of electron will be in the reverse direction. And the bond moment will be this. So this is the bond moment. This is the bond moment. And this is the resultant bond moment. So in this case, what will happen? In this case, you will find this is the bond moment, and this will be the resultant bond moment. So this is the BM bond moment, and this is the resultant bond moment. So they have the same magnitude because they are being created between two carbon-chlorine bond. This is also carbon-chlorine bond. So the resultant bond moment is same. So in that case, what is going to happen now? The one resultant bond moment will cancel the other resultant bond moment. So in CCl4, one resultant bond moment cancels the other resultant bond moment between, between two carbon chlorine bonds. Hence, CCl4 is non-polar and has zero dipole moment. Please remember. So please don't judge the polarity of molecule by counting the number of electronegative elements. Okay? Dipole moment. Huh? That is mu is equal to 0.00 divide. Now I draw it very nicely. So we have done CCl4. So now we'll do say I have taken now here CH3Cl. So I'll draw it big. Yeah. H Cl. This is the bond. This is the bond. This is the bond moment. See here, it is now ulta. So this bond moment will come in this direction. This is going in this direction. This is coming in opposite direction. So in that case, what will happen? You have to subtract this from this. So this will be the resultant bond moment. So this is resultant bond moment of CH bond. And this is resultant bond moment of CH and CCl bonds. You have to add it, but here this factor is less. All right. So in this case, first of all, this molecule is polar. This molecule is polar. Don't write. Now I'll go for CH2 Cl. See here. This. Here it is what? This and this. This is the resultant moment of CH RBM of CH bonds. Okay. And here, see, is it not the same direction? Both of them. What will happen now? Look at the line. Is it resultant bond moment of two CCl bonds? All right. So both of them will be same, or This will be more than this, or this will be more than this? Tell. Start thinking, huh? Start thinking.
Sir, Cl will be more than hydrogen. I
Huh?
mean, than H.
Hey, I'm talking about a molecule, not of bonds. Which dipole moment of these two molecules will be same or different? If it is different, then which is more different? Which is more? Huh? I've drawn it for you. Look at this bond moment. Hello. So whenever I ask question, why do you keep quiet? You don't understand English.
CH2
Yes, yes, yes.
Cl2 than 3Cl
3Cl.
because there is
Which one will be more?
Sir,
CH2 Cl2.
CH2Cl2.
Achha, see here. Look at this. I told you. In this case, both of them are in the same direction, so this is the resultant moment. In this case, what you find? This chlorine is pulling the electron in this direction, hydrogen is pulling in opposite direction. So if you add both of them, the resultant bond moment of this one will be less. But in this case, what do you find? That the bond moment of both the chlorine are in the same direction. So it will be 100% will be added. Here you have to subtract this from this. Here you have to add both of them. And it will be divided by 2. So in this case, you will find that the resultant bond moment of 2 chlorine is much, much larger than this. So dipole moment of CH2, Cl2 is more than CH3Cl. Okay. Now the third situation. Third situation is CHCl3 chloroform. See here now. This is Cl, this is H, this is Cl, and this is Cl. See here, this is in this direction, this is in this direction. So resultant will be in this direction. This is in this direction, and this is in this direction. So resultant will be in this direction. Okay, so this is the resultant bond moment of CH and CCl bonds. And this is resultant bond moment of 2 CCl bond. So what do you find? Is it not this is opposing this? Is it not this is opposing this one? So in that case, what you will find? The dipole moment of this molecule will be less than this, but more than this. All right. So,
So why there is an opposite direction?
Yes, it is opposite direction, but the number of the chlorine is more. Okay. In this case, this carbon will be more electron deficient. So in that case, the bond moment of CCl will be, the dipole moment, does it not depends upon the charge separation and distance between them. So in this case, the charge separation is more. Q is more. In this case, you will find the Q is less. And in this case, Q is more. See, suppose your three of your in your house, Hey, how many brothers sister you have in your house?
Sir, 3 sisters.
Are very good. I just about to tell. So your father has to give or mother has to give pocket money to all 3 of them. And suppose your neighbor is only having 1 daughter. She also has to pay the pocket money to her daughter. In that case, whose money will be less? Your mother or your neighbor's mother? What happened? No reply. Hello.
So
Huh?
can you say again?
See, this is your mother. Okay? And this is your neighbor's mother. Then this lady has 3 daughters. Okay? So she has to pay to all 3 of them pocket money, PM. She has only 1. So she has to pay her pocket money. So which lady will have now less money?
So first
3
lady.
daughters.
It is your mother. No? So in this case, this
Yes,
is her
sir.
condition. And in this case, this is her condition. All right. So in this case, you'll find the charge separation Q. Q is more because we know dipole moment is into Q into D. All right. So draw this one. After that, I'll arrange this. Draw your classes. I think already started in school. Finish. Yeah. So now what we can write now here? That how can you arrange it? Because they have told me decreasing order always has to be done from left hand side. Therefore, dipole moment. Okay, which is going to have highest here? It is CH2 Cl. Then CH Cl. Then CH3 Cl. And this is CCl4. This is 0. I have 1 or 2 more examples that I'll give you on next day because now already is 9 o'clock.